Hey guys, Jason here, Focus Creative Studio. Thanks for joining me today. We're going to jump in and do some HO scale modeling. Specifically today, we're going to work on nuts and bolts and how I use those to really embellish some details for pipe fittings for my HO scale oil refinery that I'm currently working on. So I'm going to use a couple of extensions today. I'm going to use the draw taper tool and the round corner tool. So I'll link those in the description below. And that way you have access to the locations for you can grab those if you're using SketchUp. So sit back and enjoy and we'll get started. Alright guys, so the first thing we want to do is we want to make sure that we have our units set for metric. We want to be in decimal, millimeters, with a precision of 4 places. This will allow us the flexibility to do anything we want as it relates to HO scale. So that done, and then we want to go over, we're going to be using the draw taper tool and then the round corner tool, and we're going to create these two pipe sleeve flange fittings that are on our desktop here currently. But one of the first things I want to do is I want to show you how the draw taper tool works. So if we just draw a line, we're just going to say 2 millimeters tall for demonstration purposes. You want to select the line, pick draw taper, and we'll start with a hexagon. We're going to give it, just keep things simple, 2 millimeters by 2 millimeters, the center, with no angles. And you can see that that quickly creates a hexagon shape for us to work with. Now, important to note, it creates it as a group. We can delete that, and we still have our line left that we draw. So we can come back up here, select another one. Let's show an octagon. And we'll change this from the top. We'll just go 3 by 3 and 3 by 3. And we create an octagon with a 3 millimeter dimension. So you can see the flexibility here, and I want to show real quick with the round what the taper portion looks like, just so that you understand the power of the tool. So if we go round, let's go from 2 to 1 with a default of 24 sides. So it'll give you the path of green to red. Make sure that that's what it's going to taper to. Hit yes. So you can see the tapering effect on using round. Now this is real powerful when you start getting into rivets and you want to think about orientation of the build plate and the 3D printing of your models. Because we don't always need to do rivets, bolts, details with a true 90-degree angle. Think about that relief angle, and in some cases it works in your favor, and actually adding more detail because it'll print more successfully. So we're going to go ahead and delete these, and we're going to go ahead and jump in here and get these started. I'm going to move these to the side here just so that we can keep them as a reference tool. But basically I want to start with a circle. It's 3.25 millimeters. We want to change the number of sides to 48. That puts 12 segments in each quadrant of our circle here. Delete the inside. Oh, don't want to delete that yet. Let's offset this first. 2 millimeters. Now we can delete the inside. This is basically setting up the structure for the flange that these bolts are going to sit on. If we use our push-pull command, we can extrude this 0.6. That's really the minimum flat ring that you want to do. We're going to go ahead and create this sleeve on the inside, and we're going to add some detail, even one more beyond what we have here. But we want to offset that 0.5 millimeters. We want to push and pull that 1.2, and that gets us the same as where we're at on the other example. Now, this is where we're going to use our round corner tool. We want 0.4 is where I had it, so that's what we want to set. We don't need more than 6 segments. We're going to select this outside edge, and you can see that's green to green is where it's going to curve from. A red is what's going to disappear. Hit enter. Done. Now I also want to go ahead and put one down here like we're simulating a weld seam, but I don't want it to be 0.4. I only want it to be 0.2. Enter. And now you'll see it filled in this inside. Just go ahead and delete that. And you can see we've got a nice smooth seam here for a welded joint for a pipe flange fitting. Now let's go ahead and recreate our nuts and bolts. I'm going to start in the center just because I know where my dimensions are, and I only want to create a bolt that is, let's go 0.6 millimeters tall. Select this, come up here to draw a taper tool, and we'll go back to the hexagon. We want to go 0.875 by 0.875. That's approximately 3 inches. And we get a nice group there. We want to move that up 0.6, and that puts us flush with the top of this face. Now we're going to slide this along that red axis. Excuse me. And it looks like let's go 4.5, see where that drops it. Yeah, so that works great. So now what we want to do is we want to go ahead and keep that selected. We're going to use our rotate tool. Make sure you select the center of the circle. Come out here on that red axis. You can see my line out there. Click a point. Now it'll rotate it, but we want to hit control first. Now it's going to make copies. We're going to go 20 degrees. We've created one. Now we want to fill the full circle. So we're going to hit times 17. And that completes that circle for us. And you can see real quick, I've got a great pipe flange fitting with bolt heads on it without doing a significant amount of work. But now what we're going to do is we're going to take this piece here and we're just going to move that. Grab it from the bottom. I'm going to come up here and set it there. Actually, I don't want to move it. Let's backtrack here a second. We're just going ahead and draw right on top of this with our line tool. And you want to keep that on the blue axis, and we're going to go 0.4 millimeters tall. Don't need a tall bolt to stick through. E for erase. Select that, back to draw a taper, and we're going to hit round this time. Not rectangle, round. All right, we got to keep that diameter small. We want to go 0.45, 0.45. That's our 1.5 inch. And now granted, that's going to be large for a typical threaded bolt, but for the sake of HO scale, it's a good detail that prints well and gives us the illusion visually that we've got good nuts and bolts on our models. Hit OK. You can see real quick the nice detail we get. We're going to go back, use our rotate tool, back out to the red axis, or green is fine. Rotate it. We want to hit control first, hit 20, and then times 17. And there you have it. That's a fast, easy way to use some extensions for creating nuts and bolts in our HO scale pipe flanges that we use for the refinery models. Now this particular model fits over the evergreen scale models tubing 6.3 millimeters, and I generally leave a 0.1 millimeter relief tolerance around the outside edge for that to slide over those pipes. So this gives you a good quick demonstration on how to create those fittings without having to do a significant amount of modeling work. So hopefully this was helpful for you, and you can use this simple process of creating nuts and bolts for your HO scale models that you're working on by using the draw taper tool and the round corner tool. And again, I'll link these in the description below. Go ahead and smash that like button for me. Subscribe to the channel. I've got more content coming, some more live stream information coming in conjunction with Kevin Tolley with Steel Mill Modeler Supply. And we're working on a full series that really starts to develop the 3D printing aspect of how we can implement a really great technology into the practice of building our model railroads.